Hello everyone, welcome. This is our 8th episode of IEEE at Home blockchain series, the 2021 edition. I would like to ask the audience to turn on their camera. We would love to see everyone here in the session. If you have any questions regarding our presentation for today, you can put them in the chat, or you can wait for the end of the talk when we'll be having a Q&A, and then you can ask them directly by audio. For today, it is our pleasure to have here with us and to introduce to you Sarah Gayami. She is currently a technology specialist at TELUS, where she works on various software engineering projects. She has recently received her master's degree in software engineering and intelligent systems from the University of Alberta. Her master thesis received the C.R. James Award for Best Master of Science Thesis in the ECE department for spring 2021. Her research interests include distributed ledger technologies, cloud computing, and she was also a mentee in the Hyperledger mentorship program in 2020, working with blockchain interoperability. And this brings us to the session for today, a pub/sub architecture to promote blockchain interoperability. So Sarah, without further delay, you have the floor.
Thank you so much, Katerina, for that very kind and nice introduction. So I'm going to just get started. So as Katerina mentioned, my name is Sarah Gayami, and I'm currently a technology specialist at TELUS in Canada. And today, before I go into the project that I want to share with you, I'm going to first talk a little bit about blockchain interoperability and give you a little bit of background on what that is and why it is important. And then I'm going to tell you about the project that I worked on in this space called a publish-subscribe architecture to promote blockchain interoperability. This project was part of the Hyperledger mentorship program, which I was part of in the summer of 2020. During this project, I had the opportunity to work with my amazing mentors, Dr. Sarah Rouhani, Rafael Bolcher, and Professor Rick Cruz. And also at the time, I was a master's student at the University of Alberta, and my master's supervisors, Dr. Hamza Khaze and Dr. Perch Musilek, were also part of this project. So when we started this project, we had four main objectives in mind. We wanted to design a blockchain interoperability solution that can be used by Hyperledger technologies. We wanted to implement a proof of concept for the design, compare with other interoperability solutions, and analyze the performance. But before I get into the project itself, let's talk a little bit about why blockchain interoperability is important. So first of all, there are a lot of blockchain networks that are built for specific use cases, and all of them are running separately and isolated from each other. So we have these silos of information and asset that cannot really work together. This limits the potentials that we can reach with this technology because we cannot allow different networks to talk to each other. Also, different distributed ledger technologies have unique features. And I should clarify here that when I say distributed ledger technology, I'm talking about the underlying technology. Like, for example, we have Hyperledger Fabric as a DLT, we have Hyperledger Indy, we have Ethereum. These are the technologies. But when an instance of these DLTs are implemented, that's a network. Like, for example, if I use a Hyperledger Fabric to create a blockchain network, that's called network, and the technology is Hyperledger Fabric. So I wanted to just clarify this because I'm going to use these two words a lot in my presentation. So when I say different distributed ledger technologies have unique features, what I mean is that, for example, Hyperledger Indy is designed specifically for digital identity, so it has unique features regarding that use case. But Hyperledger Fabric, for example, is a general purpose blockchain. So when we don't allow interoperability, that means we cannot use the unique features of different technologies in other ones. And for each of them, we have to implement everything from the scratch. Other than that, there are a lot of distributed applications that have already been built, and they may be on different networks. If we can use those applications in our own applications, That means we don't need to implement every single functionality, but we can use those applications instead. So interoperability can be really important in this sense as well. Finally, we may need an asset from another network. So in this case, this is not necessarily an application that we need or a technology or a network, but maybe I have a specific asset on one network that I want to use on another one. Let's say, for example, there's a blockchain, there's a Hyperledger Indy blockchain, and I have a digital identifier or DID on that network, but I want to use that in another network. So this is what I mean by the last point. A specific asset that is living on one network, but we need it on another network. So we can see here that there are a lot of reasons why we may need interoperability in our networks. Now let's talk about different scenarios of interoperability that we may have. So the first thing is sometimes we want to swap assets across networks. So let's say, for example, I have some Bitcoin, my friend has some Ethereum, and we want to swap these assets. So this is different from the second point when we want to migrate an asset from one network to another one. And the second point is specific to when we want to migrate from and to the same technology. So let's say, for example, we have two Hyperledger Indy networks, and I personally have a digital identifier on one of them. But I don't want to use that anymore. I want to use another Hyperledger Indy network, and I want to migrate the asset that I have to the new one. So this is the second point. And the third one is when we want to migrate the asset to a network that has a different technology underneath it. So let's take that example again, but instead of two Hyperledger Indy networks, let's think of one Hyperledger Indy network and one Hyperledger Fabric network. I have a digital identifier on the Indy network, and I want to migrate that, excuse me, I want to migrate that to the Hyperledger Fabric network. This this is a little bit different from the previous one because we're facing different challenges. The reason is the technologies are different. This is Fabric, the other one is Indy. And the fourth scenario is when we want to query data from another ledger. So we may not necessarily need to migrate the asset or swap the asset, but we just need some information about it. So let's take a hypothetical example. Let's say, for example, we have a blockchain network that has the weather information on it. Now, I have an application that I want to use the weather information in. So what I would need to do is to just query the information from that other ledger. I don't really need to like migrate the asset or anything. I just need to query it. And the final scenario is when we want one ledger to invoke another ledger. So let's say, for example, I want to sell something to someone else. And there are two blockchain networks. One of them is responsible for the financial transaction, and let's call that the banking network or the banking ledger. Then I have another blockchain network that is responsible for delivering the product to the buyer. Now, ideally, I would like that as soon as the buyer pays for the product, the delivery starts. So basically what I want to do is that I want the banking network to initiate and invoke a transaction on the delivery network. And I want that to be automatic. So that's the last scenario when we want one ledger to invoke another one. So now that we know different scenarios of interoperability and why it is important, let's talk about different categories of interoperability. Because there are a lot of different solutions that have been proposed already. None of them are perfect, but each of them solves a specific problem that we may have. So the first categorization that I want to talk about is proposed by the World Economic Forum. If you scan the QR code on this page, you can download the white paper that they have on this categorization. And a few weeks ago, I was listening to the talk that Dr. Luke Riley gave on this categorization, and he goes into the details of each of them. I really recommend this talk if you're interested in this topic. You can reach that in the hyperledger.org website under webinars. So I'm just going to give you a little bit of overview on each of them. I'm not going to go into the details because I don't have much time on this. But okay, the first category is cross-authentication. So in this one, each side of the interoperability has to separately cryptographically authorize and authenticate the transaction. So there's no central trusted party here. There's no middleman. The networks talk directly to each other. The second category is Oracle. So an Oracle is an agent that enables the transfer of external data. And all the parties in the network need to trust that Oracle because it comes in the middle and everything goes through that Oracle. But this Oracle can be centralized or decentralized. And I personally think that a decentralized Oracle makes more sense for a blockchain network or for interoperability between blockchains because we're talking about distributed and decentralized networks. And the last category is API gateway. So in this one, each distributed ledger network has their own connector and they implement it themselves and they connect it to the API gateway. So as a result, this provides access to a lot of different distributed ledger technologies because each technology can implement their own connector. Another interoperability categorization is proposed by my mentor, Rafael Bolsher. If you scan the QR code on this page, you can download the survey paper that he has written on this topic. The first category, the first main category is public connectors. So any interoperability solution that wants to allow interoperability between public blockchains falls under this category. So the first one is sidechains. In sidechains, the idea is to offload the transactions and the interoperability to the sidechain and not use the main chain for the whole thing. The second one is hash lock time contracts. In this one, the idea is that cross-chain atomic operations happen using smart contracts. Then we have notary schemes. Here, these are trusted parties that help participants of one blockchain network confirm transactions of another blockchain network. The next main category is the hybrid connectors. Here, every interoperability solution that wants to connect a public and a private blockchain network can fall under this one. The first category is trusted relays. Here, the trusted parties that the trusted relays are basically the trusted parties that redirect transactions from one blockchain to another one. Then we have blockchain agnostic protocols. These platforms allow arbitrary distributed ledger technologies to interoperate by providing a blockchain abstraction layer. So the first network doesn't necessarily need to know how the other blockchain network works because everything is abstracted from them. And then we have blockchain migrators. Here the idea is to migrate a state of a blockchain to another one. Finally, we have blockchain of blockchains. Here, these are frameworks that provide reusable data, network, consensus algorithm, or even smart contracts. And each blockchain network can come in and use these reusable parts to create a new blockchain. So this one cannot be used for blockchains that already exist. But when the blockchain is created with the same parts and with the same underlying reusable parts, then the blockchains that are created can easily interact with each other. So with that, I'm just going to dive into our project and our solution. So our idea was to use the publish-subscribe architecture to allow interoperability in blockchains. So imagine a source and a destination network that want to talk together. The source network we call the publisher, and the destination network is the subscriber. The idea is to have a broker blockchain that comes in the middle, and it basically handles the connections and the transactions. So our broker blockchain has two smart contracts. One of them is the connector smart contract, which is responsible for handling the connections and talking to different blockchains. The topic smart contract is responsible for keeping track of the messages and the information about the assets that are being transferred. And each of the publisher and subscriber networks that want to connect to the broker, they need to implement a connector smart contract. Now, we have implemented some of these smart contracts for some of the technologies, and I'm going to talk about that later on, but it can be written for other technologies as well. There is no limit on that. So the first thing that participating blockchains need to do is to enroll in the broker blockchain. So both of our publisher and subscriber need to do that. And then when they enroll, the publisher can create a new topic. And when a new topic is created, all the other blockchain networks that have the subscriber role can come in and subscribe to that topic. From that point on, every time the publisher updates the topic, all of the subscribers will be notified of the change. So they don't really need to go ahead and keep checking the publisher to see how that asset or how that information has been updated. They will be notified. And that's really nice because they don't need to keep checking. So I talked about the two smart contracts that the broker blockchain supports, and I want to tell you a little bit about the specific functionalities that they have. So the first function is init ledger, and we have that in all of the Fabric smart contracts. That's basically the function that runs at the beginning when you initiate the smart contract. Now, in the connector smart contract, the create blockchain function is used by all the networks, all the blockchain networks, when they want to enroll in the platform. Then we can use the unique ID, excuse me, the unique ID of each blockchain to query more information about it. And we also have the function query all blockchains to see how many blockchains are out there, which ones do what, and the information about each of them. In the topic smart contract, the create topic is used by the publisher to create a new topic. And then the unique ID can be used for querying that topic and information about it. And you can also query all the topics that are in the platform to see what there are and which one you're interested in. The subscribe to topic and unsubscribe from topic are used by the subscriber to keep track of what they want to do with the topics that they have. And finally, the publisher uses the publish to topic to update the information that they need and let everyone know that the information has been changed. So to make sure that our design is feasible and it works, we implemented a proof of concept for the design. All of our code and documentation can be found on the Hyperledger Labs GitHub page. If you scan the QR code on this page, you can go to that link and check out the details. So we implemented the broker blockchain using Hyperledger Fabric version 2.2. Then we used Hyperledger Caliper to analyze the performance. We used Hyperledger Explorer to monitor what's happening in the network. And we also implemented publisher and subscriber networks, but these are just example networks. We can have many more of these. We just wanted to show that this solution can be used by different permission blockchains. So we use different versions of Hyperledger Fabric and also Hyperledger Bezu. So we implemented a publisher network using Fabric version 2.2, and we implemented two subscriber networks using Fabric version 1.4 and Hyperledger Bezu. But why did we use Fabric for the broker? So first of all, we wanted to have a solution for permissioned blockchains and permission interoperability in them. So as a result, our broker had to follow the same pattern and the same level of access as our other blockchain networks. So we needed a permissioned broker, and Fabric is a permission blockchain. Then most of the permission blockchains are used by enterprises, and it was important to have a solution that is designed for enterprises, and it really fits with with what we had in mind, because Fabric is designed for enterprises. Also, Hyperledger Fabric is modular and configurable, and it allowed us to try different configurations and see which one works best with our solution. Finally, Fabric supports smart contracts written in general purpose programming languages. And as a result, we were able to write complicated smart contracts and really achieve what we needed to do because we used general purpose programming languages and it was easy to implement stuff. So here I have a demo for you of the platform. I just want to show you how it works and give you an idea of what it is. So here first, you can see that Hyperledger Explorer page, and this is for the broker blockchain. Here I want to show you that before we begin our experiments, we have 11 blocks and 11 transactions on our network. And we're going to come back to this page after we finish our experiments and we want to see how that changes. So here you can see 4 windows. The top left one is the broker blockchain. The bottom left one is the publisher. And the 2 right windows are our 2 example subscriber networks. The top one is the Fabric subscriber and the bottom one is the Bezu subscriber. So the first thing that I want to do is that I want to query all the topics that are on the broker. I want to make sure there are no topics because I want to start the experiment from the scratch and I don't want anything on the networks. So I do the same thing for the publisher as well. I just want to make sure there are no topics there. The next thing I want to do is to create a new topic from the publisher network. So I give it a name, here is first topic, and a message, which is initial message here. Then I'm going to query the publisher and see if the topic has been created. And we can see that it has been created with the same message and name. And if you query the broker as well, we can see that the topic has been created with a unique ID, blockchain3_0, and a list of subscribers that is currently empty because we just created the topic. So the next thing I want to do is to make sure that this topic does not exist on the subscriber first, and then subscribe to that topic from the subscriber. Okay, now we can query the subscriber again, and we can see that the topic has been created on this network. And if we query the broker as well, we can see that blockchain 0, which is our Fabric subscriber, has been added to the list of subscribers. And I want to do the exact same thing for my Bezu subscriber. First, I check that the topic does not exist here. And then I subscribe to that topic. Now, if I query again, we can see that the topic has been created on the subscriber. And if we query the broker again, we can see that blockchain 1, which is our Bezu subscriber, has been added to the list. So the next step is to update the topic. I want to publish a new message to the topic from the publisher network. So I want to change the message to new message. And I expect that all of my other blockchain networks get notified of this change. So let's query the broker first. We can see here that the message has been updated to new message. And if you query the subscribers, we can see the exact same thing. So they were all notified of the change. Now, if we go back to the Hyperledger Explorer page, we can see that all of these experiments that we did has resulted in a few blocks added and a few transactions added to our network. Okay, so I mentioned earlier that we used Hyperledger Caliper to analyze the performance of our network. So what we did was that we changed the transaction send rate throughout time, and we monitored the transaction throughput and the average latency. And you can see the results in this plot. And we did that for every single functionality that our broker blockchain supports. Now, there's a lot of detail here in this figure, but there are a few things that I want to point out. First of all, we can see that the publish to topic function has a different send rate, and it's acting a little bit differently from the rest of them. And the reason is that we understood the publish to topic function is the bottleneck of our network. So we couldn't really increase the number of transactions that we're sending because we reached the limit, and the throughput got capped and it got limited, and the average latency was increasing, and it gets even up to like 80 seconds, which is a lot. And if you look at the query topic, we can see here that the send rate and the throughput are following the same pattern, and the average latency is always below a second, and it's really small. The reason is that we didn't really reach the limit of our query function. It seems like everything is working perfectly fine. And if you look at the subscribe to topic, unsubscribe from topic, and create topic, we can see that they're following the same pattern. From some point on, when we increase the transaction send rate, the throughput is capped and it doesn't increase anymore, and the average latency gets higher. And that makes sense because we've reached the limit of our hardware at that point. So what are the next steps in this project? First of all, we can add support for other permission blockchains. We currently support Hyperledger Fabric and Hyperledger Bezu. We can work on adding other blockchains as well. Also, we can work on adding an access control layer. So right now, all the topics are accessible by everyone in the network, but maybe some publisher doesn't want to share everything with everyone. Maybe they want to control who can access the topics that they're sharing. So we can add another layer to allow that functionality. Also, we can work on enhancing the performance. We already know the bottleneck of our network is the publish to topic function. So we can work on enhancing that. And also we can work on enhancing the transaction verification. Right now, we're just using the default Hyperledger Fabric verification, but we can add more functionality to this and see how we can verify based on the networks that are participating. Finally, this project can possibly be integrated with Hyperledger Cactus in the future. Hyperledger Cactus is a blockchain interoperability solution that is pretty recent, and I think it can be beneficial for that project and for this project for these two to be integrated. Thank you so much for listening. That's for my presentation. I'd be happy to take questions now.